Welcome to the Advanced Microcontroller series. So in this series we will learning about PIC16F877A Microcontroller. So before moving to this topic, let's discuss about the introduction of microcontroller. And this session will cover the following topics: introduction, types and working, general architecture, microcontroller versus microprocessor, choosing a microcontroller. So what is microcontroller? What it will do? So it is a IC, which is capable of being programmed to perform a specific task. That is nothing but microcontroller, not general purpose task. It will perform a specific task. A microcontroller includes built-in processor, memory, in-out ports, communication ports. So here we are not using the external components, all are built-in. So the processor that runs instructions, memory to store programs and data, in-out ports to connect with buttons, sensors, screens, etc. Then communication ports to connect with other devices. So what are the applications? The microcontroller used in embedded system. So for example, security system, laser printers, automation system, robotics. So all these places we using the microcontroller. So here you see this is the microcontroller. It having inbuilt ADC, analog to digital converter, digital to analog converter DAC, then clock, inbuilt RAM, CPU, ROM, all are inbuilt. So no need external components. So the types of microcontroller. So based on the memory or devices, instruction set, bits and memory architecture, we classified microcontroller. So based on memory or devices, microcontroller can be classified into two types: embedded memory microcontroller, then external memory microcontroller. So what is embedded memory microcontroller? So all functional blocks are built into the chip. So here no need external memory. So it includes program memory, data memory, in-out ports, serial communication, counters, timers, interrupts, all are there. For example, 801 microcontroller, it has everything on the chip, but external memory, it does not have all functional blocks on the chip. Some components like program memory need to be connected externally. So for example, 8031 microcontroller does not have the program memory on the chip. And based on the instruction set, we have two types, RISC and CISC. So what is RISC? Reduced Instruction Set Computer. So here simplifies the instruction set using fewer and simpler commands. But in CISC, it is complex instruction set computer. So it allows complex instructions that can do multiple tasks in one command. So in RISC, allow instructions to work on any register and access program and data simultaneously. So it allows instructions to work on any register and it accesses program and data simultaneously. But in CISC, it reduces the need for many simpler instructions. So in CISC systems, shorten execution time by reducing the number of instructions in a program. In RISC system, shorten execution time by reducing the clock cycles per instruction. So these RISC systems generally offer better execution performance compared to the CISC. And based on bits, the microcontroller can be classified into three types: 8-bit microcontroller, 16-bit microcontroller and 32-bit microcontroller. So the internal bus is 8 bits in case of 8-bit microcontroller. Here internal bus is 16 bits wide. It will providing better precision and performance than 8 bits. But in 32-bit microcontroller, so the microcontroller use 32-bit instructions for operations. And here in 8-bit microcontroller, the ALU performs operation on 8 bits at a time. So for example of this is 8051 microcontroller, PIC1X. In 16-bit microcontroller can handle a wider range of numbers compared to the 8-bit range. So example is PIC26 and 8051XA. And in 32-bit microcontroller, it is used in advanced applications like medical devices, engine control systems, office machines and other embedded systems. So example microcontrollers are Intel or Atmel 251 family. PIC3X is the example of this 32-bit microcontroller. And another type is Harvard and von Neumann architecture. It's based on the memory architecture. So let's discuss about this later. So working. So how it will work? The working of microcontroller. So microcontroller is essentially a tiny computer on a single chip combining a CPU, RAM, ROM, in-out ports, peripherals, ALU, clock, etc. So how it will work? First it will fetch. So here you can see so first it will fetch, then it will decode, decode, then execute, then output. See here LED turn on. So this is the working of microcontroller. So first it will fetch, then decode, then execute, then you will get the output. The CPU reads the next instruction from the ROM. So the CPU reads the next instruction from this ROM. The program you wrote is stored in this ROM. So the CPU reads the next instruction from this memory. So how it read the next instruction from this memory? Using a program counter. So the CPU will use the program counter to read the instructions. So that tracks where it is in the code. So that's all about the fetch. Next is the decode. The CPU interprets what the instruction means. So for example, turn on a pin, like turn on LED or add two instructions. So the CPU interprets what the instruction means. That is the decode. It will decode. After that it will execute. So the arithmetic and logic unit is there, right? ALU. So it performs the actual operation like adding, comparing, switching pins on and off. So after this, the output. The result is sent to the in-out pins, where connected devices like LEDs, motors or sensors respond accordingly. So no direct human interaction needed here. Then LED will glow in case of turn on LED. So that is the output. In case of adding two numbers, you will get the output or sum here. So communication with other chips happens via protocols like UART, SPI, I2C, CAN or USB depending on the applications. So the ROM stores your program permanently. RAM holds temporary data while running. The CPU runs instructions like fetch, decode, execute. This ALU does math and logic operations, and in-out ports connects to the real world LEDs or sensors. And here we having clock times everything, typically megahertz speed, and here we using peripherals. So that's all about the working of microcontroller. And next is the general architecture. So here we considered von Neumann architecture and Harvard architecture. So what is von Neumann architecture? So both are the digital computer. So in von Neumann architecture, so here you see this design is based on the concept of stored program computers. So where program data and instruction data are stored in the same memory. But in case of Harvard architecture, program data and instruction data are stored in the different or separate memory. So this is one difference between these two architecture. So the fact that all data and instruction are stored in a single memory space, it helps the process of designing a computer system, as there is no need to create complicated systems of routing since pathways may coincide. So that is the advantage, and it is cost effective. A smaller number of components is needed as compared to the other architectural designs, and a program can always be changed or altered without experiencing a change in some underlying physical aspects such as circuitry. So this is flexible. So that is the advantage. But in case of this, the availability of two buses, right, instruction and program data, for data address and instruction address. So here we using separate memory. So the availability of buses also separate. So the availability of two buses for data and instructions avoids a problem of contention where only one bus is used, and this enhances the velocity of the system. But here we using same bus. So here in the Harvard architecture, the chance of memory corruption is at least cut in half, since data is not stored in the same locations as instructions. So it will improve the security, and it is efficient use of resources. So why? Because it enables the use of different memory for data and for instructions of different sizes, as this helps in optimal utilization of the buses and other resources. So that is the advantages of Harvard architecture. But it have disadvantages also. So in von Neumann architecture, the shared bus can be a problem because the data and control instructions cannot be obtained simultaneously, and therefore it becomes slow. And since the data and instruction reside in same memory, then there is a temptation of one erasing the other, thereby producing system faults. But in case of this architecture, we are using separate memory and separate bus. The design and implementation of the Harvard architecture is more intricate. So here we using other hardware facilities also, and cost also high. So the concept of Harvard architecture calls for two sets of memory and two separate buses. So their implementation costs are comparatively high than the von Neumann architecture. And changing or even improving the system can also be a little tricky because of the different memory regions. So these are the difference between both two architecture. So in von Neumann architecture, it is used in personal computers and small computers, but Harvard architecture, it is used in the microcontrollers and signal processing. The PIC16F877A microcontroller belongs to which architecture? Let's see. The difference between microcontroller versus microprocessor. So before explaining this, I will give a simple example. So microcontroller, imagine like a packed lunchbox. Everything like CPU, memory controls is already inside one tiny chip. You just give it power and it works perfectly for simple jobs like reading a temperature sensor or blinking an LED. But microprocessor, so imagine a powerful brain without a body. The CPU is very powerful, but it can't do anything alone. It needs you to connect the external RAM, storage, display controllers, etc. before it works. So that's why laptop is bigger and more expensive. So now, what are the difference between microcontroller and microprocessor? We got some idea. So here you can see the difference. The microprocessor is heart of the computer system, but this microcontroller is heart of the embedded system. So microprocessor is just a processor, and we need to connect everything externally. Memory, in-out components have to be connected externally. But microcontroller has external processor along with internal memory and in-out components. All are built in. And in microprocessor, memory and in-out has to be connected externally. That we already said. So it becomes large. But in the microcontroller, all are built in. Memory and in-out are present internally. So it is small. And cost also low compared to the microprocessor. And microprocessor cannot be used in compact systems. So that is inefficient. But we can use microcontrollers in compact systems. So it is efficient technique. So the microprocessor using external components. So the entire power consumption high, and it is not suitable to use it with the devices running on stored power like batteries. And microprocessors have less number of registers, so hence more operation are memory based. So memory and in-out components are all external, right? So each instruction will need external operation. So it is relatively slower, and most of the microprocessors do not have the power saving features also. But in the case of microcontroller, most of the microcontrollers have power saving modes like idle mode, power saving mode. So it will help to reduce the power consumption even further. So here external components are low, so total power consumption is less, and it can be used with devices running on Stored power like batteries. So here all components are internal. So most of the operations are internal instruction. So speed also fast. And it have more number of register. So but in microprocessor we have less number of register. So the microcontroller, here the programs are easier to write. The microprocessors are based on von-Neumann architecture. So here program and data are stored in the same memory. Microcontroller is based on the Harvard architecture. So program memory and data memory are separate. So where we are using microprocessor? It is mainly used in personal computers, but microcontrollers are used in washing machine, MP3 players, security systems. Now, how to choose a microcontroller for your project or for your applications? So how to choose? So this is the first and important question before picking any chip. You must know exactly what your device needs to do. The application decides everything else: speed, memory, in-out pins and more. So example, your aim is to blinking a LED. So which microcontroller you will use? 8-bit microcontroller. Then for motor control, 32-bit microcontroller. For smart home, you are going to use ESP32. For medical devices, certified microcontroller you are going to use. So choosing a microcontroller. So first we know exactly what your device needs to do. Next is the performance. So performance means clock, speed, RAM and processing power. More performance costs more money and uses more power. So always choose the minimum performance your application needs. And next is the price. So price is not just the chip. So it includes all supporting components, PCB, tools and development time. So in mass production, even 10 rupees 10 difference per unit means lakhs saved across thousands of units, isn't it? So the price also important concept while choosing a microcontroller. Then availability. So a chip you can't buy is useless, isn't it? Always check it if it's in a stock, easy to reorder and supported long term. So during chip shortages like you are going to do the production from 2020 to 2027, but shortage happens during 2024. What you will do? So many products are stopped because of this reason. So because their microcontrollers was unavailable, so you need to verify the end of the life of microcontroller, whether it is available or not. You need to know. And availability of tools. Even a great chip is painful to use without good tools. So you need a compiler, debugger, libraries and community support. So poor tooling can add months to your development time. So because of this, price also increasing, right? And special capabilities. So some microcontrollers have built-in superpowers that save you from adding costly external components. So one built-in feature can simplify your entire design. So always choose the microcontroller. So always choose the minimum chip that satisfies all 6 factors, not the most powerful or expensive one. So that's how you need to choose a microcontroller. So That's all about the today's session. In the next session we will be discussing about the embedded programming and project creation. So thank you all.